We have learned something today. So in this lecture, we will have a quick look at operating systems, because that's obviously an important component in IT systems. So if we look at the 4 themes that we are covering this year, we have now finished with the web of data. Pushpa gave you the last 2 lectures, last couple of weeks. Looking at your submission, it looks like you quite enjoyed it somehow. Web prototyping, there's still 1 lecture left, but I want to make sure that you have completed your database work and MySQL so that we can go to JavaScript. IT fundamentals, we haven't done much so far, so today we are going to do the 3rd part, and then Pushpa later on will deal with opportunities and trends. Okay, so a bit of feedback about activity 13. So generally, I think around 50 people submitted. I think everybody did well, except people who didn't manage to provide a link, a working link. They still tend to put things on the cloud and it's protected, or so I cannot check your work. So this to learn about analytics, you go to a tutorial, then you follow the instructions. I think it's an interesting technology, but I don't think they're that difficult to get. Obviously, some people try to do some analytics on their website, and their blog, for example, hasn't been very active, so you didn't get some that interesting statistics. Some people ask me about analytic tools for Facebook, particularly. Again, Facebook, it's a very big thing. You can use Facebook as a tool for communicating with your friends, or you can use Facebook as a way of doing business. So obviously, you're not going to use the same tools for measuring those kind of traffics. So instead of giving you one name, I gave you a few links about tools for social medias in general. So some experts have analyzed a set of tools with their pros and cons. So please refer to that if you are interested. And then I had a cheeky question from someone who wanted to know how many users are going on my website. First of all, I would like to stress that my website is not aimed at the general public. Okay. And also somehow I cheat. Because first of all, in order to complete your activities, you have to go to my website. So I have already a captive audience of 200 people who have to go regularly on my website. Otherwise, I use my website to disseminate my research results. So they are for experts in computer vision and bioinformatics. So again, it's a very specific audience. There are not millions of experts. So I don't really track people going on my website. What I do, I track people citing my papers using other tools. So I know that more than 600 people have cited my papers in their own publications. So somehow finding my work useful. So activity 13, again, is make the effort. Usually you will get there. Just provide a valid link, otherwise you will not get the marks. activity 14. So here we had fewer submissions, 37, but again, the quality is good. So people chose a variety of data sources: Facebook, Oystercard, Taobao, Twitter, Flight Radar, Reddit, Amazon. And Pushpa reported some of the interesting findings you provided. So now we know that we have 7.6 million Oyster cards were issued in 2013. If I remember well, the population of Greater London is 6 million. It's 8 million, okay. So it's roughly one Oyster card per person, which what you would expect, more or less. So statistic about Amazons, that seem to be quite busy. Again, how much Facebook and Twitter work in terms of processing data, huge amounts. People interested in e-commerce and Alibaba with impressive results. Someone asked a specific question about usage of open data, and Pushpa has recommended a couple of websites. So if it's of interest, please have a look. So generally for activities 13 and 14, I think it's more about getting your hands dirty. You know, if you start it, follow the instruction, read the tutorials, you will get there. There is no intrinsic complexity. So today I would like to give you an introduction about operating systems, because everybody knows a bit about operating systems. You may be using different types of operating systems. So let's have a look at them. So each time you have a CPU, so a microprocessor, there is an operating system running a system on that microprocessor. And you can see that microprocessors are not only what we call computers. Now they are everywhere. Obviously they are in your phone, in your PlayStation, but they are also in your car and possibly in your fridge, in your phone, in your telephones. They are everywhere. So this lecture will be quite interactive, so you can get your clickers out. So nowadays everybody has at least one computer. Most people have several devices which can be called computers. I think it's 3. 0, 3, yeah. And so if we go back to the origin of computers, so you had this CEO of IBM who made a prediction in 1943 about the computer world market.
It's not open.
It's not open. There's no sticker either.
I think it's 62.
62?
I connected on 62.
Okay. But nobody has
No, it's not 62.
managed to. So you have tried 03,
Yeah.
02. Okay, that's quite annoying. It's specified polling open. Yeah, so the channel is 03. Let's close.
Green
Green
arrow.
pause a little if you want to do that one again. The little green arrow, circle arrow to the left.
Green arrow, this one?
Yeah.
Can you click here or not? No. Okay, so we need to accept that there's a technical problem. I guess we can use our hands. Okay, so what was the world market according to the CEO of IBM? Answer A. Yeah, majority going for A, so that's correct. I mean, I gave you this piece of information as start of the lecture, I think in October, so it's good that you can remember it. So obviously, at the time, computers were huge machines. Okay, they looked a bit like that. So a computer would just fit in one room of this size. So they were only used by big countries. So you could have one computer for the US Army, one for the Soviet Union, one for China, possibly one for Britain, and maybe France, and that was your market at the time. Yeah. Obviously, things have changed from a unique computer for one country, which moved to one computer for one company. So everybody had terminals sharing times on that specific computer. And so that's very important because at that time, the first operating systems were created. And what was the operating system used for those big machines?
DOS.
No. Unix was Unix. So when we will look a bit further into the details about Unix type operating systems, you can see that it's still working the way it used to work at those times. You had one big machine and many users trying to grab a bit of processing power on that big machine. Okay. And then the computer became personal computer. Okay, so initially it was at work, part of if your job involved dealing with data, you were provided with a desktop computer. And obviously nowadays computers are everywhere, work or leisure. And we are going to the embedded computer. I don't know if you have heard about that cyborg from Reading. No, there's a crazy professor who has implanted some microchips into his body, and interestingly, they are connected to his nervous system. So it means that remotely you can interact with his nervous system. And he gave a very interesting talk at the Café Scientifique. Don't know if you've ever been. It's the last Tuesday of every month at Woody's in Kingston by the river. So it's a pub. And there is a world expert coming and telling you about their work. and there's no PowerPoint, okay, it's just a pub. So there's a guy standing in a corner of the pub telling you about their fantastic work, having a pint at the same time, and it's a very relaxed atmosphere. It's for the general public, so you don't need to be an expert in the field. So that guy from Reading came and told us about his adventures using his implanted chip. I understand that his wife has an implanted chip as well, and they are able to communicate in some ways remotely. So, interesting stuff. So yeah, so maybe we will all have an implanted chip in the near future, instead of having a bulky mobile phone in your pocket that someone can steal. You will have a chip, someone hidden in your body, and you will communicate through that. Sounds good, isn't it? Okay, so have you heard about Moore's law? Again, we don't have clickers. So, which answer seems the most probable for you?
C.
Yeah, C, sure. There's confusion now between B and C. Yeah. I mean, it's true that, I mean, the answer is C. However, when we speak about it in the media, very often we speak about B. You know, it's a shortcut because many people don't have an understanding of what transistors are. Okay. So if you tell people, yeah, now you have double the number of transistors, yeah, who cares about the number of transistors? But if we tell you, yeah, now your computer is going twice faster, thanks to some technology improvements, that makes sense. Okay. But the actual Moore's law is about the number of transistors. Okay. So the actual prediction by Gordon Moore, so person who co-founded Intel, okay. So that was in '65, and he said that the number of transistors in a chip would double every 18 months. Okay. And that's a prediction he made in 1965. And it's still true. You know, that's a remarkable feat in technology to be able to predict things for even 50 years later. The number of transistors is still doubling every 18 months. Okay, you can see the curve is fitting quite well the different data points. Okay. However, now if we speak about computers' power, processing power, so Moore's law is only one factor of why a computer is going to go faster. Okay. So Moore's law is here, that's the green one. Okay. Number of transistors increasing, so the more components you have, obviously the faster you will get. Another thing which was very important is the clock on your microprocessor. How many operations it can compute in a second. Okay. And interestingly, until 10 years ago, you know, each year you would get a processor going faster and faster. So that was another way of getting more power of your computer. You had more components and you were processing them at a faster rate. However, that is over. Now the clock speed of computers doesn't change anymore. Why? No. The problem is heat. Okay? You are reaching thousands of degrees because it's so quick, it generates so much heat that you couldn't afford to go faster. Okay? Everything would melt. Okay? So that way of getting faster capabilities is over. Okay. So that's why for a long time, the power of computers were not doubling every 18 months, but it was doubling every year. Okay. But now the speed component, we have lost it. Okay. So now it's just the number of processors, transistor which is increasing. So is it going to carry on? Because the prediction for 50 years is pretty good. Is it going to hold 100 years? And I don't know if you have followed, but you should follow, that many people are saying, okay, now is the end of Moore's law. Okay, we will not be able to sustain that anymore. You know. So in 2003, Intel predicted that it would stop now, basically. Moore's himself say that there is a limit. Okay, you are going to make transistors smaller and smaller, but at some point the transistor will have the size of an atom. Can you get a transistor smaller than an atom? I mean, we know that now we have discovered the quarks boson. So are you going to have quarks as transistors? Possibly not. Okay, so there is a physical limit. More recently, so a theoretical physicist said that there was still 10 years to go. Okay, so the end would be 2023, which is still coming soon. So basically, the end is near. Okay, we are not going to get more processing power anymore because of the smaller size of transistors. Another issue is that the smaller you make your transistors, the more errors you are going to make in manufacturing those microprocessors. Okay. Already there are sterile environments. You don't want a piece of dust to be around in the room because that can make your component faulty. And now it's more and more restrictive because you are dealing with things which are smaller and smaller, which means that the price of those components is increasing a lot in price. Okay. So what is the solution? Instead of having smaller components, you double the components. That's the multi-core strategy. Okay, so that's the easy bit. You use the old technology and you put 2 in your computers or 4 instead of 1. And you go 4 times faster in principle. Okay, so that's the lazy way of increasing your processing power. But again, there is a limit, okay? Because at some point your box is going to be too big. Yeah. So the good days of computers getting all the time better will be over soon, I think. Except if we use some completely novel technology. People have been working on quantum computers. If I remember well, at the moment they are able to make additions of numbers of 2 digits, which is a great achievement, but it's far from what we are asking from a computer nowadays. Okay, so obviously the power of your machine, one aspect is the hardware, and one aspect is how you are using that hardware. Okay, because obviously if the software is doing a good job, you are going to harness more of that power. I mean, typically at the moment when you're using your multi-core system, very often you're only using 1 core per application. So you have 3 cores which are asleep and 1 application struggling with 1 core, okay, which is not a good usage of your machine. So I suspect that in the future, programmers will need to have a closer look at the hardware which is available. At the moment, they tend to not to worry too much about it. Okay. So, and that's the problem is it comes from the operating system. So the operating system is, if you want, organizing the execution of all your programs on your machine. Okay. And it allows the user not to worry about the hardware. You are basically, your application doesn't communicate directly with the hardware, it communicates with a layer, which is your operating system. So somehow the operating system is trying to make you believe that all machines are equivalent. So you have a piece of software for one operating system, you go on your super duper machine at home, on a netbook, or at the library, and your software works the same way. It may be a bit slower, but it will keep the same functionalities. Okay. So the user basically only worry about the application. The operating system which is used, they have only a very far view of what it does. Okay. Why are they choosing Windows instead of Mac? Because of the look, because of the price, because they are told it works a bit better, but they don't have an understanding and don't exploit the particularities of the different systems. Then there is the developer, the IT specialist, and most of them are dealing at the application level. So they are writing applications usually for one specific operating system, but they don't worry about the hardware of the machine. Or they just have specifications. You need that amount of processing power at least in order to run my piece of software. But they are not going to alter the way the software works according to the machine you have. So basically they are not exploiting the full power of your machine. Then there is a layer of the operating system, and obviously some IT specialists will specialize on that. Okay. Some of you will be designing maybe components of operating systems. So in order to do that, you will need to have a very good understanding of the hardware in order to exploit it the better way you can. So that at the application level, the operating system gives at the application level all the possibility to exploit the hardware as much as possible. So obviously as an IT specialist studying the topic, you need to have an understanding of those, a good understanding of those two layers, and at least a basic understanding of the hardware. Okay, so what is the most popular operating system?
Linux. Depends on whether it's computer or server.
Yeah, I think that's the right answer. This question doesn't really make any sense. Okay, so just a tricky question. You know, for what? Okay, so I'm going to reformulate the question. What is the most popular operating system for PCs now? Yeah? Or you can shout, we are not that many.
Windows.
Yeah, Windows. Great. So according to the latest statistics, 90% of PCs are running Windows. Okay. I mean, that's an important statistics to know. Okay. You know, if you are serious about being an IT specialist, I think it's a good idea to have some understanding of Windows. Okay. Otherwise, a big part of the market will be missing. So you have 7.68% using Mac, 1.71 using Linux. Okay, so Linux sounds quite big. A lot of people speak about Linux, but it's a tiny part on the PC market. Okay. If we look at the trends, people are using Windows 7. Windows 8 has been a total flop. It turned out nobody was interested in it. It's now going down already. And with Windows 10 has been launched last year and is slowly taking over some of the market of Windows 7. Okay. We can see that the Mac system is very tiny in terms of users. But maybe people are using Linux and Mac on their PC, not because they want to use it on their PC, because they want to learn the operating systems for other usages. Okay? Because the PC market is just one of the computer markets. So what is the most popular operating system on mobile phones now?
Android.
Which?
C.
Android? Windows? Nobody for Windows? No? So again, a very different picture. The first system is Android, almost 60% of the market. Then we have the iOS from Mac, almost 33%. Windows is tiny with just under 3%. Okay. So again, if you want to become an app developer for mobile phone, studying Windows is not going to get you much on the market. Okay. So maybe people who have a Mac as a PC is because in the background they say, I want to learn the Mac operating system so that I can develop on mobile phones. Okay. So you need to think about those things now. You know, you are here to learn. You are at university, and everybody in the university, we are offering you a Windows system. Why would you buy a Windows system? Is it a good move? Maybe it's better to try to acquire new knowledge in the other systems. Get a Mac or Mac is already quite good for mobile phone. We will see if Linux has any value somewhere. But you need to get that in the back of your mind, you know. Am I going to be a Windows specialist, only Windows specialist, and only working on PCs? Or in my career, I intend to do different things. Here we can see that basically Mac is going down, Android is going up, and the other ones are hardly existent. But what about web servers? That's a completely different world. But maybe some of you would like to be on web servers, you know, to be on the back of all those websites. So it's another big part of the market. So which would be the most popular operating system there? Linux. So Apache, that's running usually with Linux, is number one with almost 40% of the market. The number two is Microsoft. Okay, so we can see that a couple of years ago, even Microsoft was above Apache for a few weeks and went down again. Okay. Another important system is NGINX. It's again an open source one, and as you can see, the trend has been pretty good. So maybe it's one to watch. Okay, keep an eye on those statistics. Go back to the websites regularly. Maybe that's where your next job is, because very few people know that system, but it seems that there's a good trend about it. Maybe it will fall again, okay? I mean, you can see that Sun, for example, in the 90s had a good peak there, and then fell down again, okay? Obviously, there was the competition of Apache at the time, and basically Apache won. But you need to follow those trends, because that's where the jobs are, okay? So obviously, you need to know the main system, but following the trend and be specialized in something that other people don't know can be a very valuable asset. So we have seen different systems for different applications. What about supercomputers? If you want to work for NASA or for the big system that Google has, for example, what operating system would you use? Linux? Yeah, not sure. The picture is very simple. Linux is the solution, okay? And if you are not using Linux, you need to use Unix, who is the grandfather of Linux, okay? Mac tried and failed. Windows tried and failed. There's only Linux in the market, okay? So again, when you are buying your next computer or when you are installing an operating system, you need to think about those things. You know, where do I see myself in the future? Do I see myself in web servers, supercomputers? So better to learn about Linux. If you see yourself more into mobile, maybe Mac or something around Android, you have these computers with Android systems as well. So think about those things, okay? Because the easy thing is to get Windows. But if you want to stand out, maybe not getting Windows is a good option, a better option. Because Windows is everywhere, you will learn it anyway. It's like foreign languages. English is very useful. You already get it for free, but there is brownie points for people who can speak another one. No, it's a serious question. There are computers on Mars, okay? These little robots, they have computers, they have operating systems, obviously. So what kind of operating system you have there? I mean, it's quite a special environment, okay? I mean, if you crash, you cannot press the reboot button. Yeah, you need to think about that. So maybe Windows wouldn't be a great option. I mean, it doesn't crash that much anymore, but it does crash sometimes, okay? So you wouldn't like to be at risk of that. Do you think that Linux would be good enough? Actually, no. They have their own operating system, okay? It's a very specialized operating system because you are to deal with a situation which is very different. It needs to be real time, okay? When your system is analyzing, you have to react, okay? You are about to fall in a crater or whatever, you have to react. You cannot afford the standard operating system which works according to, let's say, when you run on your PC, what the operating system is trying to do is to make your journey of your work comfortable. It's about comfort. When you run a system on Linux, what they try to do is make everything fair. Okay? It's about fairness. So that if there are several users, everybody feels that they have their fair share of the system. Where we are on Mars is not about being comfortable and being fair, it's about survival sometimes. Okay? So let's forget about fairness and comfort, and so let's survive first. So you need a completely different types of operating system. So, and also obviously the type of computers you have there are very specific as well. Okay? So you can see that the small computer that is on this machine is not very impressive. Okay? 256 megabytes of RAM. I don't think you can get that anymore on a PC. Okay. And obviously you have a lot of specific hardware, some instruments to collect information. Obviously you have all those systems working at the same time. Okay. So you have radar, cameras for navigation, at the same time you are trying to monitor the atmosphere. You have all those things running at the same time, and your operating system needs to make sure that the most important system can always take the top priority. Okay, you are in a mission, you are trying to find life and stuff, but now your system is in danger. You have to shut up everything else and concentrate on navigation, okay, or using some emergency system. So as we said, you cannot reset the button. I mean, now there are 2 robots on Mars, so maybe one could come back and press the button if needed. Functions are also time critical, okay? You can only communicate with Earth and at certain times of the day. You need to be on the right side of Mars when the Earth is at the right part. So communication is a bit complicated, and you need to make sure that if you have a window of a couple of minutes for exchanging data, that your system is ready during those couple of minutes. Okay? So you have constraints that you rarely find on other computer systems. So they are looking for some evidence of life. They believe already that life may have been around a long time ago, but they are still looking for life around today, and the jury is out on that. A nice sunset on Mars. Sun a bit smaller than here. Okay, so we have seen that there is a vast range of operating systems. They have been somehow specialized in very specific type of hardware systems, mobile, PC, server, supercomputers, and then very specific applications. Their main goal, really, is to make sure that the program that the user is running without any troubles, okay? And it's doing the communication between that program and your hardware. So you want the hardware to be used efficiently, but you don't want to bother about it. You don't want to know about it, okay? You want to be able to run your software the same way, whatever machine using the same operating system. The system obviously is trying to make sure that you can, for example, run several software at the same time, okay? And that your keyboard can be used in one piece of software, but in another piece of software as well. So what the operating system is doing a lot is to share resources. This application needs the keyboard and needs a bit of memory. That one needs that. And I want to run both at the same time. How do I do that? Obviously, that allows you to have portable software. Your Windows application will be running on your laptop and on a desktop as well, even if the hardwares are different. What we need is the same operating system. Obviously, the operating system has also to do with everything which has to do with security and protection. Okay. And basically, the reliability of what you are running on your computer will depend on the quality of the operating system. So that's why for application where reliability, like the computer on Mars, you need some type of operating system. When you are using a supercomputer, each time you run a piece of code, it costs you thousands of pounds. So you don't want it to crash, okay? On the other hand, when you are running something on your PC, if it does crash, usually it's not the end of the world. You restart your computer, get a coffee, and you are back. Yeah. Obviously, reliability has a cost. Okay, if you double check everything all the time, you are going to go twice slower. But that will depend. How do you deal with error, with faults? How do you reconfigure your system and so on? So, as we have seen a little bit about the hardware behind a computer, you have different components. So you have your microprocessor, you have the disk controller dealing with what is on your hard drive. You may have some USB controllers dealing with your mouse, your keyboard, your printers, and other devices, and other controllers dealing with your monitor, and you have the memory. And information is moving between these different blocks through a common bus, okay? And memory is usually a unique resource which is shared by all those systems. So your operating system needs to make sure that everybody has their fair share of, for example, the memory. So an operating system can be seen as a resource allocator. Okay, you have several systems running, all wants to be allocated some memory, some processing power. How do you do with that? If you have maybe 4 cores, if you have 4 applications, that's quite easy. 1 application on each core. What do you do if you have 10 applications which are open? How many applications do you have open in general when you are running your PC? 10? You have a browser somewhere in the background. You must have an email system or 2 running at the same time. You may be listening to some music. You may have a Word document, a PDF with, you have a huge amount of application running at the same time. And you are not going to have generally as many cores as applications. So you have to share somehow. So the operating system is allocating resources, but also controlling the execution of programs and how you are interacting with inputs and outputs. And then you have what is called the kernel. So that's some kind of program which is running all the time on your machine. Okay. So that's a program which making sure that everything is working, so that's the core of your operating system. So you have this program, and then you have the program which are dealing with resources about the applications that you have chosen to run. Okay, so instead of speaking about 4 cores, let's go with 1 core situation, which was still very common 5 years ago. So you need to write your report, listening to some music, and be alerted about incoming emails. Okay? So reasonable usage of a computer. However, your PC has only 1 CPU. So it means that you have only one processing unit, so you can do only one of the three things at a moment in time. Okay. So the solution is to do multitasking. Okay. So the different jobs have to share the system. You spend a bit of time on your report. Very quickly, you are checking the email, so you stop the reports thing. Quickly, you go to the email, get the latest bars of music, and go back to your report. And all that, I mean, that's what's happening all the time. And if this is done well, you are not aware of it. Okay, you are writing your report. I don't know how fast you are typing. Okay, but let's say you are typing maximum 10 characters a second. Okay, so if between 2 characters it managed to go away, do something useful, and go back, for you it doesn't change your life. Okay, it doesn't slow you down. Okay, so that's what a good system needs to be doing, being able to handle a lot of applications at the same time, but for the user, they don't notice that it's happening. Obviously, you have issues of priority. Okay, hopefully, since you are working on your homework, your report is your priority. Okay, so you want the system to make sure that while you are typing your report, it doesn't hang on and you have to wait for and go back because it didn't type and so on. So you don't want that to happen. Okay. Incoming emails, I think that should be kind of low priority. Okay. If an email arrives now and you are alerted in 1 minute instead of now, does it change anything? Not really. Yeah. You will still feel, oh, yeah, an email has just arrived. I got it 1 minute after the date. It's an acceptable behavior, and you are not complaining. You will feel that your system is working well. So the email system will be with a very low priority. It's really when nothing happens, it's going to check the emails, using a bit of processing power. You are listening to some music. That should have quite a high priority, because if you wait 1 minute for the next bit of the next note, that will change a bit of your experience. You want something continuous. Okay, so your operating system has to juggle with that. Okay, with all those priorities to make sure that you have the best experience and you feel that everything is going smoothly and everything is happening at the same time. Obviously, the more application you open at the same time, the more the system is struggling, and at some point, it just breaks down. Okay? I mean, I'm sure you have all seen that. When you are trying to run some application which are a bit, try to use Photoshop and some very advanced functions, needs a lot of processing power, and everything else freezes in your computer. So the operating system needs to prevent that. Okay, a good operating system. So the solution, as I said, is time sharing. You have this unique processing unit and several applications. The alternative is you may have only one processing unit and many users. Okay. So that was what happened 20 years ago. You have this big machine in that company, and everybody has a terminal sending some jobs, and the processor had to share between all those users. Okay, but it's conceptually the same problem as one user with many applications. Okay, obviously, if you have a web server, that's a similar system. You have one web server and many users trying to get resources on that web server. So again, sharing time is a very important functionality of your operating system. So what are the main components? You want to be fair, especially when you are dealing with different type of users, you want everybody to feel that they have the same amount of processing power. You don't want the first user to get 90% of the processing power and the other one sharing 10%. You are going to, if it's this unique computer in your company, you are going to complain. This guy is doing all the resources, I'm not getting it. Or if you go on a web server, you want to feel that, okay, I have to wait a little bit for getting the information, but I'm not waiting more than my neighbor. So that's okay, it's fair. You want the operating system to writing an email report, your email system is at low priority. Okay. You want the system to be also efficient. Okay. You want to make sure that the components are used as their maximum as they can, that you don't have too much, the response time is quite low, and obviously that you can use all those different applications at the same time. And obviously, although you need to find a compromise between those criteria, because if you discriminate, you are not going to be fair. It's not possible to be fair and discriminate at the same time. Okay? So the operating system needs to find some kind of strategy, which is there is some kind of discrimination, but at the end you feel it's a fair solution. Yeah. Okay, so we are going to look at different strategies. Okay. So let's assume that we have one processing unit, and we have 5 different applications. Okay. So we have a third application, which would take 3 units of processing power in order to be completed. We have another application, which is going to arrive, that the user is going to launch a bit later on, but that will require a longer time. A third application is a bit shorter, but launch a bit later on. A fourth one, and a very short one, which is launched at the end. Okay? And now your processor, your operating system has to find the best strategy so that all those applications are run in a fair way while discriminating the right way and giving you the best experience. Okay. So the first strategy is the first application which has been run, I run it, and when I finish with it, I run the second one, and then the third. Okay. So I'm not really sharing any resource in that way. Okay. So what happens? Application will be run in that order. Okay. However, when you are running a very short application, okay, remember that application 5 was launched at time 8. And so you started at time 8, you press the button at time 8, and it's completed only at time 20. So it's something which is very quick, and you have to wait more time than the time you need to run the application. You have to wait 5 times more just to get this answer. So the answer, you would like to get it in a split of a second, and actually you get it 10 seconds later. So very bad experience. On the other hand, if you have a long job, I want to run some complex Photoshop stuff on a big image. I know that it takes 5 minutes. If I get the answer after 6 minutes, doesn't change that much. Okay? But if I have that job, I believe I can do it in 1 second, and I get it 1 minute later, I will not feel happy with the experience. Okay? So that technique is very bad for short jobs. You have a short job, you would like it to do it very quickly, get your answer and get out. But in this system, because you have this, this queue which is piling, jobs will feel that it will need a lot of time to be executed. So an alternative strategy is what is called the round robin. Okay? So basically you are going to cut all your jobs in small portions and you run them one after the other. Okay? So which means that now your small job, you will complete it quite quickly. Your long job will need quite a long time, but it was a long job, you knew that it would take a long time, so maybe the time is doubling, but that's not too much of an issue. So that's quite a good strategy. The issue is how to cut your applications, how much time you want to give to each application. Obviously, the smaller the time, the fairer it's going to feel, because everything will change from one to the other all the time. So you will feel that everything is running in real time. However, you need to think that what your operating system has to do, you run an application, you stop it. You have to memorize where you were in the application. So you store all your variable of your application in some place, remember that you have to restart there, then you start the next application. And then you go back to for example, to the first one, you have to recover all that information to start at the right place and with the variable at the... So you have to do a lot of extra work that you wouldn't do if you were running the application in one go. Okay? Therefore, if you switch too often, your processor will spend most of this time saving the environment on the application and restoring it instead of processing the application itself. Okay? So which means that you don't want those chunks of application to be too small. If they are very small, it will feel very fair, everything in real time, but at the end it's going to slow down your system. If it's too large, then you are going back to the previous system. Actually, the application finish one after the other. Okay? So that type of strategy conceptually is good, but you need to find what is the size of the block. Another strategy could be, okay, we know that when we have a short application, we would like to get the result quickly. A long application, we are happy to wait a bit because we knew that it would take time. So an application could be, a strategy could be, when there are two processes in competition, I let the small one to go first. Okay. So in our case, we will get something like that. Okay. The yellow one will have just to wait for the orange one to finish, and it's going to be processed in one go. On the other one, the blue one, which started a very long time ago, have been overtaken by the yellow one. Okay? And we can imagine a system where all the time you want to do a small thing, which means that your long process is never going to be processed ever. So it's going to be very unfair on the longer process, because each time there is something coming, say, oh no, that's a long one. You can wait, and at the end you can wait for longer, forever. Okay, so that's the system, what is called starvation in the world of operating systems. Okay, so as you can see, no strategy is ideal. Okay, all have drawbacks, and the operating system have to choose one and try to provide you the next experience, fair and so on. So if we look at what Windows is using, so Windows is really about user experience. Okay? They want you to enjoy your time on your desktop, computer, or on your laptop. Let's forget about fairness. You know, it's about you. So it's really the PC mentality. Okay. So it's going to use a round robin. So cut the processes in smaller pieces. Okay. So that's the main strategy. However, there are going to be different lists of round robins. There will be the list with the high priority one, with the lower priority, and the very low priority. So sometimes somehow it's mixing the two strategies. The large processes after the short ones, but still we are cutting all the processes so that we have the feeling that everything is smooth and going at the same time. Okay. So it's a given compromise. Okay. And also a process, when it has been used, its priority is going down a little bit, so that we don't reuse it too quickly, so that the other ones which have never been used have a chance to get in. So that prevents you to get the starvation situation. Because that process that have never been used at some point, we have a priority which will be higher than the initial processes which have been used a lot. And sometimes their priority goes down. Okay. And a nice functionality is that if you are in a window and you type with the keyboard, priority is going up. Windows recognize, oh, he's writing on his report, typing stuff, let's boost the priority because that's what they are really interested in. Okay. So you can see that it's a strategy which is very much focused on the users, okay, which works quite well on a PC. Okay. So what is on the foreground? The windows which are visible, the window where you are typing stuff, they get the high priority. So let's have a look. You all know the task manager, processes. And you can see that you can set the priority of your processes. I don't know if you have ever played with that. Sounds dangerous, yeah? No, I use it regularly because by default, different types of programs have different types of priority. So is there anything useful? So for example, here I'm dealing with the program associated with the operating systems. They have a high priority because your operating system is really the core of your system. So that should be processed, okay? So it's more important to have the operating system running well than my PowerPoint, which is, where is my PowerPoint? Turning point, it's called here. Which is normal, okay? So when you are running applications, by default, Windows is going to set a priority, but you can change it if you want. I mean, let's say that we go back to this application, you have your Photoshop processing a big picture. You know it's going to take a long time, okay? And if your RAM or your processing power is a bit low, it's likely that it's going to freeze everything on your computer and you have to come back, yeah? Sounds like a familiar experience, some of you. So what you can do, put Photoshop at a lower priority. So it's not going to freeze your system, it's going to run it only when there is time for it. So instead of processing your whole image in 5 minutes, it will do it in 10 minutes. But during those 10 minutes, you will be able to browse, to write your report and stuff, okay? So it's a very it's quite important, if you want to be an IT specialist and use your system the best you can, you need to play with those priorities. Okay. In the worst case scenario, your computer will crash. Okay. I mean, if you play with the priority of the operating system and you put it a low priority, that you are going to get a catastrophe. Okay. On the other hand, if you play with your own application, your browsers and stuff, you may feel it's more responsive or less responsive, but it's worth, playing with it and to get a feel and to learn how to use it, because that will make your life easier and you will get a better experience. So have a try, maybe not running stuff which is too important when you are playing with it, but get a feel, because I found it a very useful tool. Or if I'm running some heavy computing and I'm going for lunch, I put it high priority. I don't care, it's going to freeze everything, but at least it's going to, all the other applications will be put in the waiting list. I go back from lunch, everything has been computed much faster than if I let it normal. Okay. So you need to be able to control that. And you need to have some understanding about the operating system, how it works, so that you can control it some way according to your knowledge. Okay. Yeah, so usually the Windows stuff is high priority on Windows. Okay, so what about Linux now? Okay, so as I said, Linux is the grandchild of Unix. They are very, very similar systems. And as we have seen, all the supercomputers are using Linux on Unix. So they are inherited this idea that you have a machine with high performance computing, and then you have plenty of users trying to use that machine. Okay? So what is important is to be fair. More than the experience. The user knows that there's only one machine and is going to be shared by 10 people. So it doesn't expect to get a responsive machine as you would have on your PC. But it expects something to be fair. All of the 10 users should have the fair share of the processing power. So that's the philosophy, the initial philosophy of Unix, and which has been transmitted to Linux. Again, they are using a round-robin strategy, but that's only for the real-time processes. So the stuff you touch your keyboard, the thing which need quick reaction. Otherwise, for the other processes, you will get credits for these processes. Okay, you are allowed 5 units of processing. Everybody is allowed 5 units of processing. Everybody has used their 5 units. Now they get 5 new units. Okay, so you have this fair system where all processes get as much processing power, except the processes which are required to be real time, like dealing with input and outputs. Okay, and if you don't have more credits, you just have to wait. Everybody else is using that credit, and then nobody has credits, you give credits to everybody again. Okay? So that system is based on the idea of one big machine shared with a lot of people, but obviously you can use the same system on one machine shared by a lot of applications. Okay? However, you can see that now is to be fair between applications, which is not the same as quality of experience for yourself. Okay. So conceptually, Windows on a PC should be a bit better than Linux as an experience on your machine. But maybe you are running Linux for other reasons, to further your career in supercomputers, web servers, or because the system is usually more robust. It's going to crash a little bit less because it was designed to work with huge machines. One single machine is a big company. You cannot crash that. Everybody is going to complain. Okay? So design with different type of philosophy, at the end of the day, the quality of the experience is not very different for the average user. But you need to be aware of that. Okay. There are many issues of securities, because now you have all those processing working at the same time, or not really at the same time, one after the other, but they are all sharing the same memory. So you want to make sure that there is no overlap. You want to make sure that if one crashes, everything else is not going to crash as well. Okay? So security is the main issue for operating systems. If we look at the size of the number of codes, lines of code in the operating systems, I didn't get figures after Vista, but it's going up. So you can see that the space shuttle had an operating system with very few lines. Okay. And now, to get your Windows running, you need tens of millions of lines. Okay. It's believed that now we are in the hundreds of millions of lines, even more. Okay. So obviously, those systems are going to have bugs. Hundreds of millions of lines, sure there are problems. Okay. So it's really tricky pieces of software to manage and debug and so on. But they are really critical to your computing facility. Okay, so that was a brief introduction about operating systems. Now you know roughly what they do, why they're important. But now I want you to interact with them. Okay? So far you have been most of you have been passive users. You don't really care about the operating system, you don't know about it. You just say that it's one brand and another, and you have been told this one is better than that one. Now I want you to basically go to the dark side. Okay? We are not interested anymore in the nice Windows environment. We are going to do, there's still a bit, but I'm going to do a demo, so don't need to pack yet. You need to go inside the machine, okay? And do things that the normal user couldn't do. Obviously now you can break everything as well. It's a bit annoying if you don't do it well, but you will get power that the average user doesn't use. I mean, I don't know if you are sometimes interacting with the technicians at the university. Usually when they have a problem, you don't see a Windows interface. I mean, a window interface, whatever the operating system. They go to the dark side, okay? They go there. You know, that's where they work. You know? Like you can see in these old science fiction movies, you know, that's where they work. Because that's where the power is. You have a nice, fancy interface, but what you can do is very limited. Okay? You have to choose within a menu, and you have a few options. If you are an IT professional, you want to be able to do anything you want. Okay? So this activity is about that. Okay? Get you to the dark side. So let's go to the dark side on this computer. You know how to do that? Run CMD. Here I am. So obviously you need to learn a set of commands. You type your commands. nothing has happened, but, and now if I do, I have created a file with all the content of my directory. How do you do that with your Windows interface? How do you want to retrieve the list of all your files? You cannot. It took me 10 characters. Okay, now I have a file with all that, and I can use it. I can use the information for doing things. Okay, if I want to rename all my files, I type the right function, and automatically everything is going to be changed. Okay, so it allows you to do a lot of stuff that you couldn't do with the nice interface that the average user is using. Okay, so again, if you want to be serious and become an IT professional, you need to know about those things. Okay, because I don't know, how would you get the list of all your files in a directory? Windows, do you have to type everything? I don't know. I mean, I have no idea how you would do it. But now I can do it in 1 second by knowing how to use. So here is the DOS environment, which is behind Windows. Okay, so you have a lot to learn about that stuff as well. Okay, so it's not just about HTML, PHP, Java. There's a lot to learn also at the level of the operating system. Okay. And obviously here I can put priority, I can put securities, you know. I want this file to be accessible only by myself. Even if it's on a shared drive, this file can always only be seen by myself. Or this file can be seen by anybody, but I'm the only one who can change what is inside. Okay? All that stuff, you can control it there. Using your Windows interface, I think it would be quite complicated. I'm sure you can download some app which allow you to do that. So basically, all those instructions, they will have bottled it, and you will be able to use a set of more advanced instructions than what Windows offering you. Okay, but you need to learn about that stuff. Okay, so in this activity, I want you to learn about how to handle this Windows operating system. Okay, all of you have access to Windows machines, even if it's at the library. Yeah, you have access to the library? Good. So you all have access to a Windows machine. How is the black side, the dark side on Mac? Yeah, it's a good question, because they like to do it differently. So the dark side on Mac is white. Okay, you will have learned something. The dark side is white on Mac. Okay, so if you have a Mac and you want to experiment, here is how to get there. Okay, and it's going to be, it's a different operating system, so it's going to be a different set of comments. Okay, hopefully, I mean, usually, as you know, in programming languages and commands, they try to use English words which are meaningful. So it's not, but you need to practice as well on that type of environment. So in this specific activity, I'm asking you just to work on Windows, not on Mac, because not everybody has access to a Mac computer. And I want you to work on Linux as well. And you have all access to a Linux machine. You know that. You have all bought space on a Linux server for where your blog and your website is. Great, you have access to a Linux machine. What a coincidence. I tell you that it's very important and you already have access to it. So now you can go on your Linux machine, you have paid some good money to have access there, and now you can use it. And you can look at the dark side on Linux as well. Sure, you will have fun. So thank you very much for your attention. Next week is reading week or announcement week or whatever week. No lecture week. And I see you again in 2 weeks' time.